4.6. Discuss the BCS theory. The accepted explanation is known as the BCS theory, where BCS are the initials of three scientists who developed the theory in the 1950s. That is, Barden, Cooper and Schrieffer. Imagine part of the solid lattice of the positive ions in a conducting material or ceramic. As an electron approaches it, attracts the positive ions and distorts the crystal structure slightly, as shown on the right. And you can see that there by the approaching electron, moving the positive ions closer to that charge. This distortion concentrates the positive charge in this part of the lattice and attracts other electrons. In a normal conductor, this distortion leads to collisions and loss of energy by flowing the electrons which repel each other. This is the normal electrical resistance within a conductor. But the key thing here with superconductivity is that in a superconductor, below its transition temperature, something very strange happens, and this is called the quantum energy effects, where two nearby electrons pair up to form what is called a Cooper pair. Cooper is the C in the BCS theory. So the Cooper pair is shown on the diagram below the first on the top right, and you can see that the Cooper pairs of two electrons will form together to move together along that positive ion concentration at its minimum. So these Cooper pairs go freely across and are concentrated between that tunnel of positive ions. So due to the quantum effects, each electron of the Cooper pair helps the other pass through the lattice without any loss of energy, which is what we need. This means there is zero resistance. However, at temperatures above the transition, the thermal vibrations in the lattice keep breaking the Cooper pairs as fast as they form. This destroys the superconductivity and the normal electrical resistance of the substance returns. So the key thing is keeping the temperature below transition, which is looking at type 1 and type 2 superconductivity, which will form Cooper pairs, which ideally gives us zero resistance and giving us electrons flowing in one direction.